Welcome back, everybody. We're going to finish up our Chapter 1 notes on math review and intro to physics, and most of what we're going to spend time on here is the factor label method. Now, if you've had chemistry before, you may recognize this. Maybe you don't recognize the term factor label, but it's very much like you might have done a chemistry that is like stoichiometry. It is changing one unit to another, converting maybe atomic mass to grams and grams to moles and that kind of thing. If you did that, if you had chemistry, chances are you probably did that before. This is going to be very much like that, but we're going to be converting miles to meters and inches to centimeters and so on and so forth, like that. So just to make sure everybody has the same background, even if you didn't have chemistry before, this is what the factor label is about. It's about converting units. And I'm starting on this slide right here, but we're going to come back to this. Let me instead go to a blank slide and sort of give you sort of an example right here. All right, so let me go to this blank one. And the first thing I want you to think of is that this number right here, 36, it really doesn't have any meaning unless there is a unit attached to it. For example, 36, is it miles? Is it kilometers? Is it inches? That's a big difference in all those, in the amount that you're measuring right there, and the difference depends on what the unit is. So we're going to say 36 miles, all right? And we want to, let's say we want to state that in a different unit. So we want to go from 36 miles to the equivalent amount, but in centimeters, okay? The reason that I made the point that it's meaningless without units is that units are very important to this factor label process, just in the same way that that variables are in algebra. For example, let's say, let me go over to the right-hand side here for a second, and I'm going to say that we've got this value of 6x over 3x. Okay? What is the value of that? Well, you say that value is 2, right? It doesn't matter what x is, because what happens to x? Well, it cancels out, right? X goes away if you have a value in the numerator and a value in the denominator. 6 miles divided by 3 miles, 6 kilometers divided by 3 kilometers. Whatever it is, it doesn't matter because it cancels out. And the point here is that units, like miles, inches, kilometers, or whatever, can cancel exactly the same way that variables can, like unknowns, like x, y, or z, something like that. So let's go back to our main value right here. We want to convert 36 miles into a certain amount of centimeters, all right? We're going to take 36 miles and just go ahead and write it. This is our initial value right here. 36 miles, all right? Now, so here's what we're going to do. What would happen if we were to take 36 miles and multiply it by 1? Times 1. Nothing happens really, right? Because it just stays 36 miles. What if we multiply it by 1 again? Of course, it's still 36 miles. It's the same thing. Times 1 again, same thing. Why are we doing this? Well, the point is that if you multiply anything by 1, it doesn't change it. It stays the same thing. Okay, so, well, who cares? So what? Well, what if I multiply this by 2 over 2? What's that fraction equal to? It's equal to 1, so it doesn't change anything. Okay? Still, so what? Who cares? What if I were to multiply this by 3x over 3x? Okay, same thing. It's still 1. What's the point? The point here is that in the same way that we talked about how x's and y's can be canceled out, we can say that units, like miles, can be canceled out as well. So what we can do is we can craft a fraction. We can create a fraction. I'm going to make big brackets right here. That is equal to 1, which means the numerator and the denominator are equal amounts. And if that fraction has the right units in it, we can get a unit that we don't want. We want to convert from miles to something else. We can get a unit to cancel out and convert to something else. All right, so what I'm going to do is this. Since over here in my original value I've got miles in the numerator, I'm going to create a fraction that has miles in the denominator. All right, and in the numerator, I'm going to put some sort of a measurement or some sort of unit or value that I can convert miles to. For example, feet. All right, now we just have to make sure that we have the right amounts of miles to feet in order for the top and bottom to be equal and have that fraction be equal to 1. All right, you may know that 1 mile is 5,280 feet, 5,280 feet right there. So let's ask ourselves, is this fraction equal to 1? Yes. So it's not going to change the original value. But the more important thing is the fact that miles over here on the left and miles here in the denominator on the right cancel out. And as long as we do our math, 36 miles times 5,280 feet, divided by 1, but it doesn't change anything. That'll give us the equal amount, the equivalent amount in feet. All right, now we want to go to centimeters. Okay, so what we can do is we can multiply it by 1 again. You can multiply something by 1 a million times, right? And it'll still be that same something. So let's create another fraction right here. We want to get rid of feet and go to, do you know the conversion to centimeters? I don't, but I know from feet to inches. I do know that. I do know the fact that 1 foot is 12 inches. Top and bottom are equal. Our fraction is equal to 1, so we're not changing the value of it, but we are able to cancel out feet because feet's over here in the numerator, feet is down here in the denominator. As long as now we multiply by 12, we have the equivalent amount in inches. Last step right here. I'm going to convert from inches to centimeters. All right, happen to know the conversion from inches to centimeters. That's 1 inch equals 2.54 centimeters. And that will give us a final answer in centimeters. Why is that? Because inches cancels out, because it cancels out just like any other variable. If you were to have x in the numerator and then in the denominator, it would go away. So we multiply all the way across the top. Now, this chunk right here I just did for purpose or for just demonstration's sake, but you could multiply it by 1 by 1 by 1 times 2 times 2 or times 3. But we're going to actually ignore that. I'm going to put a big X over all that because that is meaningless with regards to our problem. But we take our 36 and multiply it by 5,280 times 12 times 2.54. And if there was anything in the denominator, we'd multiply them together too and divide by that. But that would give us our answer. That would give us our final answer, which I'm not even going to do right now. If you're interested in finding out what that is a lot of centimeters. I would say that's probably in the order of millions of centimeters. I'll just do it right now. Why not? 36 times 5,280 times 12 times 2.54. That gives us 6,122,822.4 centimeters. That's how many centimeters are in 36 miles. So we've not changed the actual value. All we've done is change the unit that we're measuring it. 36 miles equals 6.1 million centimeters. Same measurement, just different units. So that's what factor labeling is. Taking these labels or these units and turning them into different quantities, you might say. Okay? So let's go back to our notes right now. All right, we're going to convert centimeters to meters, and this should be easy. I actually gave us sort of a difficult one. All right, but 122 centimeters. Let's go ahead and just write that. Let's write a fraction that is equal to 1, but it has the purpose of canceling out the centimeters. Can we go from centimeters to meters? Yes, we can. I think most people probably know that. It's 100 centimeters equals 1 meter. So that gives us 1.22 meters. The centimeters cancels out, so we no longer have that to deal with. We have our final answer in meters, and that's going to be what we have right there. Kilograms to milligrams. I'm actually going to do this a slightly longer way, meaning I'm going to do one more step than I have to, but that's for the purpose of showing you how this works. 2.3 kilograms. All right, there should be a point right there. I'm going to go from, first of all, if I want to cancel out my kilograms, I'm going to put it in the denominator right here. So kilograms. And I'm going to go from kilograms to grams. just because, let's pretend I don't have my metric units memorized and I can't go right from kilograms to milligrams. But I know that in 1 kilogram, there's 1,000 grams. Okay? Now, kilograms has gone away. It cancels out. I'm going to have an answer in grams right here. But I don't just want grams. I want milligrams. And so I'm going to make one more fraction right here, going from grams to milligrams. The grams, it just so happens, goes away, or it will once I have this fraction balanced right here. And it so happens that 1 gram, oops, I'm writing in red. I should write in black. 1 gram is 1,000 milligrams. All right? 1 to 1,000 milligrams right there. All right? So we take 2.3 times 1,000 times 1,000. That's 2.3 million milligrams in 2.3 kilograms. All right, milligrams are much smaller, so there should be a lot more of them to equal the same amount of kilograms. That should make sense. All right, is this making more sense to you? Well, let's try a few more right here. Then we'll talk about order of magnitude operations or calculations, and then we'll be done. Okay? Here we have meters per second. Oops, don't want to do that. Meters per second to meters per minute. All right, so this is the unit, you might say, is a fraction. But all we're changing is what's in the denominator right here. So let's go 24 meters per second. All right, and we want to go to meters per minute. So that should be a time sign right there. Let's make a fraction. And we want to go from seconds to minutes. So seconds starts out in the denominator right here. I want to put it up here in the numerator because then it will cancel out. That'll go away, that'll go away. We can go from seconds to minute as long as we have the right amount to the right amount. It should be 60 seconds to 1 minute, right? A fraction is equal to 1, seconds goes away, and we have now an answer in meters per minute, right? So we just take 24 times 60. What is 24 times 60? 24 times 60 is 1,440 meters per minute. I kind of wrote that backwards right there. That's our answer to the first example. All right, 36 kilometers per hour to, okay, now look, we're converting two things. We're converting kilometers to meters and hours to seconds, but it's exactly the same thing. Let's change kilometers to meters first. All right, let's set up our fraction right here. Kilometers is in the numerator, so we're going to put it in the denominator. And I can convert to meters because I know that 1 kilometer is 1,000 meters. Kilometers goes away. Great. We're going to have an answer in meters per hour. Oh, but we don't want meters per hour. We want meters per second, right? So now we have to take care of that hour. Here's the hour in the denominator. Let's put it up here in the numerator. All right. And let's convert to seconds. I happen to know the conversion from hours to seconds. 1 hour is 3,600 seconds. If you didn't know that, you could convert hours to minutes and minutes to seconds. So that'd be 1 to 60 and then 1 to 60, but this goes right from hours to seconds. I happen to know is 1 to 3,600. So let's find out what that is. We're going to multiply across our top. That's 36,000, right? Divided by 3,600. What's the answer going to be in? Oops, our hours canceled out, right? What's our answer going to be in? It should be in meters per second, and that's what we want, right? So 36,000 divided by 3,600, that comes out to 10 meters per second. And that's our final answer. All right? All right. That is the factor label method, and you're going to be doing a lot of conversions like that. The benefit of this is that this is all in one calculation. You're not doing a lot of little calculations. You're putting it all in one and then doing one number crunch all the way at the end right there. That minimizes error and enables you to see all the conversions all at once. I am not going to go to order of magnitude calculations. Well, you know what? I will. I've got 30 seconds. I'm trying to keep this under 15 minutes, so I'm going to quickly go to order of magnitude calculations. Order of magnitude calculations is simply kind of a ballpark estimation based on how many, sort of like factor labeling, how big or small a number should be on the order of 10. We call these Fermi calculations sometimes. If you can estimate something within an order of 10, that is, if you know there's roughly on the order of 10 of something versus 100 of something, or 10 of something versus 1 of something, you can do kind of an order of magnitude calculation. Enrico Fermi was famous for these. One that we might do would be to maybe guess on how many, or estimate how many piano tuners there are in Chicago. All right? Well, how can you possibly know that? Well, you might know that there are a certain number of people in Chicago, and I'm not even going to give you these values right here. I'm just going to say people to the Chicago city, all right? So that would be like people, PPL, to Chicago, okay? Kind of like a fraction like we just did, like meters per second, all right? We've got households to people, households to pianos, how often pianos are tuned time-wise. This is the number of hours per week, all right, certain number of hours per week and certain number of weeks per year. And so if you know all these conversions, you can create an estimation of how many piano tuners there may be in the city of Chicago based on this, this principle of magnitude calculation. Like I said, Enrico Fermi was famous for this. I'll be doing a little bit of this in physics, but not too terribly much. So there you go. It took about a minute and 30 seconds extra of your time. That's what order of magnitude calculations are, and that is the end of our Chapter 1 notes. So thanks for watching. If you have any questions, please make sure you ask me. But in the meantime, I'll see you on the next one.